Hello everyone, welcome to the LMS initiative of Department of Collegiate and Technical Education, Government of Karnataka. Myself Ekati, a selection grade lecturer in the Department of Chemical Engineering, is here today to present the first session of the course Particulate Technology. So this is a course that is being offered to the Diploma in Chemical Engineering students in their third semester curriculum. Okay, before we start the discussion of first session, so let me give you an idea of what is the objective of having this course as a part of curriculum. See, particulate technology is that subject in the chemical engineering. It involves a very important operations that are very essential in chemical industrial processes. Okay, so the student, after having undergone this particular course, will be able to understand the principles and analyze and differentiate and explain the various equipments that are used in particulate technological operations. So that is the objective of having this particular course. So today we will be starting the first session of Unit 1, that is size reduction. So after having undergone this particular course in Unit 1, the student will be able to understand the laws of size reduction and know how to apply them and illustrate the operations of the various size reduction equipments or machines. Okay, so these are the important topics that we are discussing today. So first and the foremost thing is to know about the introduction to unit operations and then to mechanical operations and what is particulate technology and what is meant by size reduction. That is a title of the first unit. So then we'll be discussing the various factors which influence size reduction operation. Then we'll discuss about the nature of materials, that is various properties of materials which are subjected to size reduction and how these properties influence the operation. Okay, introduction to unit operations. So this is the introduction to chemical engineering. A chemical engineering is the branch of engineering where a chemical industrial process is studied in which the basic raw materials are converted into some useful products. Okay. So a process starts with certain raw materials which are given certain required treatment so that the useful product and useful product is obtained. The process may involve a number of steps, so where the material has to undergo a number of changes before we get the final form of the product. The steps wherever the material is undergoing physical change are called as unit operations, and the steps involving chemical changes are called as unit processes. So chemical engineering is a combination of the study of unit operations and the unit processes. Okay, unit operations are very important because this particular category contains a number of operations which are very essential in the processes of chemical engineering. So that forms a base for chemical engineering processes. So let us now see the different types of unit operations. So these are the four major categories of unit operations: the mechanical operations, fluid flow operations, heat transfer operations and mass transfer operations. So in mechanical operations, some mechanical operation or a mechanical change to the material is being given. This includes some operations like size reduction, conveying, filtration, etc. So then we have fluid flow operations, which involves the operations that involve the flow of fluids, transportation of fluids from one point of the process to another point. Here, the difference in pressure acts as a driving force for the operation. We have heat transfer operations as a next category, where we have important operations like evaporation. So where the temperature difference acts as a driving force. So then we have the final and very important category called mass transfer operations. Here we bring about a change in the composition of solutions depending upon the concentration difference that exists. So concentration gradient acts as a driving force in mass transfer operations. So out of these four major categories, the first one, mechanical operations, are the one which are studied in this particular course. So let us now see what are mechanical operations. So mechanical operations are those unit operations which involve particulate solids, means the operations which are carried out on particulate solid materials are the mechanical operations. Okay. So we have some important operations in this particular course like size reduction, that is crushing and grinding of materials, then mixing of various materials, maybe solid liquid or liquid solid materials, then classification of solid materials like screening, etc. That is where the material, the particulate material given is subjected to separation. Then we have solid fluid operations, which include separation operations for solid from the fluid. So then we have solid handling operations like storage, feeding and conveying, that is transporting solid from place to place. So we have size enlargement operations also like pelletization, agglomeration, granulation and extrusion. So we will be taking up each one of these topics in our course one by one in the coming units. So we'll be studying the principles and various equipments used in each type of operation. So the first to start with is size reduction. So before that, I told you in the beginning itself, mechanical operations are those separation operations which are involving particulate solids. So that is the reason why we have the name of this course as particulate technology. So particle technology is the science and technology that is related to the handling and processing of material in the form of particles and powders. So this includes applying knowledge to the production, handling, modification and use of materials that are in particulate solid manner in both wet and dry condition in various sizes ranging from a very small size such as nanometers to centimeters. So it has a huge scope in the industrial field. So many industries like chemical, petrochemical, food, pharmaceutical, mineral processing, that is metallurgical industries, and various other fields like civil engineering, advanced material science, then energy engineering, then the environmental engineering also adopt these operations, that is particulate technology principles to a greater extent. So that is the importance of particulate technology. So let us now start the first unit, that is size reduction. So let us understand what is meant by size reduction. It's an operation where the particles of solids are cut or broken into pieces. Or in other words, is an operation that involves subdividing the solids by mechanical means. So there is a general term called combination that is used for size reduction. However, the common terms used for this operation are crushing and grinding. So usually there is a small difference between crushing and grinding. Crushing is usually applied to that size reduction operation where the particles are reduced to coarse particles. So coarse size reduction is usually termed as crushing. Then if the particles are getting reduced to very fine size, then the term usually used is grinding. So we also have other terms for the description of size reduction operations like pulverization, milling, micronizing, etc. So these are the important applications of size reduction operations. Size reduction operations play important role in coal washeries, then ore processing industries, that is metallurgical industries, chemical industries, paint industry, cement, and food processing industries. So let us understand what are the objectives of having comminution as an important operation in chemical industries. Okay, so this is about the objectives of size reduction operation. So that gives an idea about what is the necessity of carrying out comminution or size reduction in process industries. The first thing is to increase the surface of the given material to enhance the rate of physical and chemical process. So any material that is subjected to some kind of separation or a change in a process will have to have large surface so that the rate of whatever physical and chemical process that you are carrying out on the particular material will become high. So that is the main objective of size reduction operation, that is to make the material suitable to have a high rate of physical or chemical conversion process. Okay, to affect the separation of two constituents is another important objective. So whenever a material is taken for a certain operation, so it might contain maybe two or more different kinds of constituents. So if you want to separate out one constituent that is required for the particular operation, so then you have to separate the two mechanically. So before that separation, the separation will become easier or only possible when the particle size are reduced to certain smaller size. So that is where size reduction is playing an important role. The next thing is to meet the specifications regarding the size of commercial products. So size reduction operation is not important only for the raw materials. So some products, when they come out of a process as product, may be requiring certain operations to meet the specifications that is required for end use. Okay. So here also size reduction operations are adopted to reduce the size of the products. So then to accomplish intimate mixing of solids, the solids that are used in particular operation will be mixed with other solids as a requirement by a particular process. If two different kinds of materials are there and they need to be contacted to carry out a certain chemical reaction to bring about a product, so then the mixing between the solids will enhance the contact between them. So mixing will be effective only when we have the particles of the given material in small size. So that is also an important objective of comminution. So to improve the dissolution rates, whenever certain materials need to be dissolved in a liquid or in a fluid, the rate of dissolving those solid material will be higher or faster if their particle size is less. So that is where the size reduction operation is important. So these are the various necessities of size reduction operation in process industries. So under this topic we are discussing about the different kind of forces that are used in size reduction operation to bring about the change in the size of the solids. So mechanisms of size reduction. See, there are four common ways of breaking the solids to smaller size. The important forces, that is four major forces that are used are, one is compression, then we have impact force, then attrition or rubbing, then the last mechanism is a cutting or tearing action. Okay. Let us now see when these particular forces are adopted as a mechanism of size reduction. Coming to compression, here the particle undergoes reduction in size by applying two rigid forces. That is, when a particle is compressed between two forces to a smaller volume or smaller space, they'll break into smaller size particles. So this particular force is used for coarse reduction of very hard solids where very few fines are produced. So that is application of compressive action in size reduction machines. Next comes impact force. So here single rigid force is used to bring about the reduction in size. See, here the hammer like a force is used to bring about the reduction in size. So this particular type of force is used to yield coarse particles or medium sized particles or fine particles where compression is not that effective. Okay. The third action is attrition or rubbing. So this attrition or rubbing is an action that arises when the particles are rubbed against each other. That is, scraping between the particles take place. So that causes the particles to break into smaller sizes. So it is usually used for the reduction of size of very fine products from soft non-abrasive materials. So next is the cutting or tearing action. So whenever you have to reduce the size of the material such that the size of the material obtained is having a particular type of size and shape, then you will usually adopt the cutting and tearing action. Okay. So here scissor or a knife-like action is involved. So this particular action brings about particles of usually larger sizes where the size is uniform and it do not produce or produce very few fine particles. So usually compression, impact and tearing loads are used for breaking very brittle materials like coal and minerals, whereas the fibrous materials like wood, asbestos are requiring tearing loads for size reduction. So that is a brief understanding of various mechanisms that are required to reduce the solid of size of the solids in various size reduction equipments. Let us now understand the various factors that influence a comminution operation or size reduction operation. So whenever you have to carry out the size reduction operation, so which type of machine you have to select, that depends upon what size of the particles that you are starting with in the given material and what is the size of the product you have to obtain after the operation. So we have classified the size reduction machines into four categories. The first category contains coarse crushers where the feed size is about 1500 to 40 millimeter and the product size will be 50 to 5 millimeters. So if this is the size range of feed and the product, then they are called coarse crushers. So whenever you have particles of size ranging between 50 to 5 millimeters and if you want the product or the solids to be reduced to a size of 5 to 0.5 millimeters, then what we use are intermediate crushers, intermediate size reduction equipments. So then comes the next category, fine crushers, which are usually called as grinders. Here the particle size with which you are starting the operation is around 5 to 2 millimeters. That will get reduced to a size less than 0.1 millimeter about. So fine milling or fine grinding or ultra fine grinding we call. So here the particle size is very small. We are starting with fine materials of size of about 0.2 millimeter. Then it will be reduced to a very minute size of up to 0.01 microns. So next thing that influences the operation of size reduction is the nature of materials that is to be subjected to size reduction. That is the various properties of the materials that are being reduced to in size influence the selection of equipment and the kind of force that you have to adopt to design a particular size reduction equipment. So the first, the hardness. So when the material is very hard in nature, then you have to use a very low speed or low contact machines. See, hard materials are very tough to break. So in fact, hard materials usually cause abrasion, that is damage to the parts of the equipment. So we have to develop or design an equipment for such kind of materials with a very robust construction. Is the equipment that is to be designed should be very strong, and also it is a low speed operation, means the materials cannot be reduced in size with a very high speed, and also the contact between the machine parts and the material should be minimum. So these are the things that should be taken care while you handle a material which are very hard in nature. So next comes toughness of the material. A material may be soft in nature, but if they are tough in nature, so toughness means it is the parameter that indicates the resistance to impact. That is, whenever you apply rigid force, the material won't break. They'll just deform. They'll undergo shape change, but will not break into smaller sizes that easily. So these are the materials which are usually soft but tough in nature. So these kind of materials usually pose more difficulty in size reduction operation than even the hard materials. So hard materials can be reduced in size easily if they are brittle in nature. However, if the soft materials are there and they are tough in nature, they are very difficult to break by imposing a pressure like impact. The structure of materials. So some materials having a special structure will also pose some problems during size reduction operation. The mineral substances which are having a lines of weakness, that are the planes in their structure where there are weak lines along which the material breaks when a force is applied. So such materials form flakes, and the materials the fibrous materials like vegetable drugs which have a cellular structure will form long fibrous particles when they are subjected to size reduction. So such kind of materials should be analyzed before of their structure, and accordingly we have to design a suitable size reduction equipment. The moisture content present in the feed to any size reduction machine also plays a very important role. If the material contains a moisture higher than 5%, then within 50%, then the material flow is affected. So it cannot be easily made to flow in the operation. It gets stick to the parts of the machine, then it clogs the machine parts also. So that is how the moisture present in the feed material to size reduction operation pose some problems. So it is required that the moisture present should be below 5% to carry out dry grinding or dry crushing operation. So if you have a moisture content more than 50% in the given material, then you can subject it to wet grinding operation easily. So, a moisture content between 5 to 50% is not desired in the given feed material to the size reduction operation. So the third characteristic that influences the operation is grindability index. So in fact, this is a parameter that decides how far is the given material resistant to size reduction. So this decides also what power is required to reduce the size of the given material. So the grindability index of the material is a measure of its resistance to grinding. If this value is higher, then the power consumption or the power requirement in the given size reduction machine is lower. So we need to get the data of grindability index for a given material so that we will know what is the power to be given for a particular size reduction operation. Next comes temperature sensitivity. So certain materials will undergo deformation chemically when their temperature rises. So usually size reduction operation is an exothermic operation. Due to friction, some amount of energy in the operation gets converted to heat and the material is subjected to change in temperature. That is, its temperature rises. So some materials like wax, drugs which contain oil or fat, they undergo softening due to this heat generated during size reduction operation. So for such size reduction machines, you need to make some provision to supply cooling material, so which keeps the temperature low so that the material do not soften during the operation. So next is the stickiness of the materials. If the materials is sticky in nature, that is also a problem because they get stuck to the grinding surfaces and also they'll block the openings in the machine. They'll clog the meshes of the screen when they are subjected to separation. So sticky materials are very problematic. So then soapiness. Soapiness is a characteristic, depends on the coefficient of friction. So if the material is very soapy in nature, then its coefficient of friction will be very low. So then that material usually will be slippery so that the impact or the whatever force is applying may not reach the material. So that also causes certain kind of problems during operation. So which you need to take into care before you start the operation. So some materials are explosive in nature when they are reduced to size due to heat generated and all that. So they might cause some harmful effects. So explosive material should be reduced to smaller sizes in an atmosphere which is maintained inert. That is, there should not be anything which might trigger the explosion of the material. So an inert atmosphere, so chemically inert atmosphere is required if you are subjecting some explosive material to size reduction. So hazard to health. Certain materials when they are handled pose some hazard to health. So they need to be subjected to size reduction in a confined space. So this is how the various properties or the nature of materials are influencing or causing some effects in the size reduction operation. So that is what we have studied in this particular session. So we discussed about the unit operations, unit processes, then what are mechanical operations, then we understood what is size reduction operation, the necessity of operation of size reduction, Then we also studied the nature of material which are subjected to size reduction. So with that, I'm concluding this session. Let us meet in the next session where we'll discuss the classification of size reduction operations. Thank you.